Hello, welcome to this another video tutorial lecture. In this video lecture, we are going to discuss about the impulse response of a system. And particularly, we are going to find out the answer of this question: why do we calculate impulse response of a system? And we are talking about the LTI system. LTI stands for linear time invariant system. So let's first discuss about what exactly is an impulse function or impulse signal. So mathematically, an impulse signal, or rather I should say a unit impulse signal, is defined as del n. It is represented by del function. So del n is defined as it is equal to 1 at n equal to 0 and is equal to 0 elsewhere. And a generalized impulse function is defined as del n is equal to, it is infinite at n equal to 0 and 0 elsewhere. So if we draw this impulse function in time axis, this is your time axis n, this is your amplitude axis del n. So it is defined only for n equal to 0. The magnitude is unity. So this is how a unit impulse function or a signal is defined as. Let us discuss what is impulse response of a system. So impulse response is the output of the system when the input to that system is an impulse signal. So suppose we have a system here. So I'm representing a system with the block diagram. It can be an electrical system or a mechanical system, any of the system. So suppose the input of that system is x of n, output of the system is yn, and the response of that system is hn. And if we take input, the system is equals to the impulse function, unit impulse function, unit impulse signal, then the output of this system will be equal to the response of that system, hn. So whenever the input of a particular system is equal to del n, the response of that system is known as the impulse response of that system. So why do we calculate the impulse response of a system? There are particularly two reasons for that. Mainly there are two reasons. Maybe there are more reasons, but mainly there are two reasons why do we calculate the impulse response of a system. And the first reason is the impulse response actually completely characterizes the LTI system. What we mean by this statement is we can define any arbitrary input in terms of impulse function, because it is the it can always represented as the infinite sum of time shifted and scaled version of the impulse signal. So suppose, let us take one example to understand this concept. Suppose we have a signal x of n, and x of n is, let me draw it graphically, represent this x of n. So suppose this is the continuous version of this x of n, and we have taken different samples to convert this into a discrete signal. So it is defined for minus infinity to plus infinity. This is x, this is n, this is x of n, and this is 0, n is equal to 0, this is n is equal to 1, 2, 3. The magnitude at 3 is x of 3, magnitude at 2 is x of 2, and so on, x of 1, x of 0, x of minus 1, x of minus 2, and so on. So we can define this input signal in terms of impulse signal, because these are impulses. So this impulse at n is equal to 0, this impulse at n is equal to 1. So if this is del n, this will be del n minus 1, this will be del n minus 2, this will be del n minus 3. So these are the time shifted version of the impulse signal, and these are the magnitudes of those time shifted version impulse signals. So we can define this signal in terms of impulse signal as x of n equals to summation k is minus infinity to infinity x of k del of n minus k. So this, any arbitrary input signal can be represented as in terms of impulse signal, where this is your time shifted and scaled version impulse signal. So any input signal can be represented by this. Now, since we are talking about an LTI system, LTI system is the linear time invariant system. It is linear. So LTI system is a linear time invariant system. Since it is linear, there will be no effect of scaling, and since it is time invariant system, and there will be no effect of time shifting as well. So since we can represent any input signal in terms of impulse signal, so if we know the response, impulse response of the system, we can always able to calculate the response of any particular arbitrary input signal. So this is the first reason why we calculate the impulse response of the system. Second reason, and which is the important reason why we calculate the impulse response of the system, is because the Fourier transform of the impulse signal is unity. So suppose we have x of n signal which is equals to del n, and del n is basically your impulse function. If we want to convert this signal into frequency domain, we will calculate the Fourier transform. So if the x omega is the Fourier transform, of xn, so x of omega, this del n is always unity. It is frequency independent, so there is no dependency of frequency on this signal. Okay, so suppose we have a system. And we want to know the characteristics of this system. So if we apply a signal which is equals to impulse signal del n, now we know by the properties that this del n is frequency independent. Is not depending upon the frequencies. So any system, if we apply this input to any system, since it is frequency independent, it will not change the characteristics of the system, and we will get the exact output, or rather we should say that the characteristics will be exactly known to us if this system is frequency independent. We can understand this concept with one example. Suppose we have a box. In this box we have different colors, and we don't know what exact color is in this box. It can be red, it can be blue, it can be green, any color can be inside this box, and we want to know what color is inside this box. We can give any input this box, and we can observe the output of this input, and by observation of this output we can be able to know what exact color is inside this box. So what according to you should be the input of this box? It should be any transparent color. Suppose you are giving water as an input to this box, and whatever the output comes through this box, either it can be green, either it can be blue, either it can be red, will be give the exact color what is inside this box is. So this del n, or the impulse signal, is this transparent water which gives the exact characteristics of the system. That's why we choose this impulse signal to know the characteristics, or to know the characteristics of the system correctly. Thank you.